All right, welcome back, gentlemen. In this video, we're going to look at a technique for integrating called substitution. But before we get into the actual technique, I want to kind of build up to that. So a good strategy for finding antiderivatives, remember that means taking the integral, right? A good strategy for finding antiderivatives is to actually guess an answer, okay, using your knowledge of derivative rules, and then check the answer by differentiating it, okay? And so if you get the expected result, then you're done, right? Otherwise, you revise your guess and you check it again. All right, so let me show you what I mean. All right, so I want to start by taking the derivative of something, okay? So I want you to differentiate sine of, well, let me write it a little bit differently. I want you to differentiate, and so I want you to take the derivative with respect to x of sine of x to the fifth, okay? So let's first remember how to do that. All right, so this is sine of something other than just x, okay? So the derivative of sine of something, right, is cosine of the something times the derivative of the something, okay? Do you remember what we call that, right? We call that the chain rule, okay? And then perhaps you simplify a little bit and you put the 5x to the fourth in front of the cosine of x to the fifth, okay? All right, so that's what you get if you take the derivative of sine x to the fifth. All right, so then what if I ask you to integrate, all right, 5x to the fourth times cosine of x to the fifth dx. All right, well, I hope that you see, right, a connection there. And so if I integrate this, it should take me back, right, to sine of x to the fifth. I just have to remember, because I integrated, to put a plus c. All right, so I mean, that one was a little obvious because we took the derivative first, and then all I asked you to do was to go backwards. All right. So let's look at another one. What if I just ask you, I don't give you a derivative to take first, I just say integrate, all right? And I have 3x squared times cosine of x cubed dx, okay? So it looks a lot like the one we did last time, right? Which, remember, we integrated the result of a chain rule. We integrated the result of a chain rule, and this kind of looks like the result of a chain rule, okay? And so perhaps we think, well, maybe this goes back to, all right, since all of this stuff just went back to sine of x to the fifth, maybe all of this stuff just goes back to sine of x to the third plus c, okay? Well, then how do you check, all right? So that's what you need to do on the side, all right, is check yourself. Take the derivative of sine of x cubed plus c, right? And so let's see, we're going to use the chain rule for this first piece, and we're going to get cosine of x cubed times the derivative of x cubed. And then, of course, the derivative of plus c is 0, and so that goes away. And so you can see that when you take the derivative of sine of x cubed plus c, you actually get 3x squared times cosine of x cubed, which is what I asked you to start with over here and integrate. So that one worked out nicely as well. All right, well, let me give you another one. All right, what if I ask you to integrate the cosine of 7x dx, okay? Well, if I'm thinking to myself, well, the integral of cosine is sine, so maybe it just goes right back to sine of 7x plus c, of course, all right? And then we need to check ourselves. So I'm going to come over here, and I'm going to take the derivative of sine of 7x. All right, well, let's see what we get this time. All right, the derivative of sine of 7x would be cosine of 7x, but I still need to apply the chain rule, which means I'm missing a 7. So I need to do a times 7. By the way, I guess technically I should have, ooh, that's way too big, right? Technically, I should have integrated sine of 7x plus c, but I get this, taking the derivative of 7x, sine of 7x plus c. All right, and I get 7 times cosine of 7x. All right, well, that's actually not what I started with. Okay, that's not what I started with. So then I have to ask myself, well, how on earth could I get rid of this 7 so that I don't end up with it here? Okay. And the way you, let me see, how do I want to say that? Okay, so what I need to do is I need to have something else. Yeah, let me see. I need to have something else here so that when I multiply by 7, it basically cancels out. Okay, because I know that when I do the chain rule, I'm going to have this extra 7. All right, and so what I can do to get rid of a number is to multiply by its reciprocal. Okay, and so if I put the reciprocal in front of my answer like that, okay, if I put the reciprocal in front of my answer like that, then when I take the derivative and check it, right, if the 1/7 is there, then I have to multiply by 7 and the 7's cancel, okay? And so the integral of cosine of 7x dx is not just sine of 7x, it's 1/7 times sine of 7x plus c. And so like it gets kind of crazy when there's more to it. And so guessing and checking is not really the most ideal way. So an easier way to basically reverse the chain rule is to use this technique that we call U substitution. Okay? All right, so there are some rules, right, for U substitution, and they are going to look very familiar, all right, because essentially they are the same rules that we already know. All right, so first rule, if I want to integrate U raised to a power, all right, times du, all right, I'm going to get U raised to a power plus 1. So I have to add a power and divide by the new power, and as always, add c. All right, well, doesn't that, that looks, that's like the same power rule, except instead of calling it x raised to a power, I call it u raised to a power. So here's the key, is that u is a function of, let's say, x, all right, and du is the derivative of u, okay? So that'll be important when I actually show you how to apply the rules. All right, so u is a function of x, and then du is going to be the derivative of that. All right, the next rule, we'll do some, it works for all the trig, but we'll just look at sine and cosine right now. All right, so if I integrate cosine of u du, all right, then that's going to give me sine of u plus c. If I integrate sine of u du, that's going to give me negative cosine of u plus c. right? And so I could do any of the other trig functions and put a u in place of x in the other rules that we've done. It all works out the same, all right? So if I want to integrate e to the u du, then remember that's going to be the same, e to the u plus c. And then the last one that you should be sort of familiar with already is, remember, if we integrate, instead of 1 over x, we'll call it 1 over u du, right? But perhaps you try to write that as u to the -1 du. That's usually how you figure out it's not a standard power rule, because if you add 1 and divide by the new power, you get divide by 0, so that's not okay. All right, and then just FYI, another way that you might see this is literally du on top of u, because that's actually what you get when you multiply 1 over u times du. So 3 different ways you could see the same thing. All right, and we do know that that should give us the natural log of the absolute value of u plus c. Okay, so then how does this u substitution thing work? All right, so let's actually do some examples. All right, and for our examples, I'm going to have you integrate. All right, so first example, all right, let's integrate 5x to the 4th times cosine of x to the 5th dx, okay? So when you first start looking at these problems, you kind of need to ask yourself, does anything in the problem look like it could be the derivative of something else in the problem? Okay, so what I'm talking about here is the 5x to the 4th actually looks like the derivative of x to the 5th. Okay, so you need to get into a good habit of this. All right, you need to tell me what u is. So u is a function of x, all right? And so that's going to be my x to the 5th, and I'll show you why in just a second, because then I have to take the derivative of it with respect to x, all right? And so I'm going to take the derivative with respect to x, which is a power rule, and then technically I'm solving for du. I'm separating the variables, all right? And so du is 5x to the 4th dx. Okay, so now when I replace all of that stuff in the problem, so I'm going to come back over here and I'm going to rewrite the problem. 5x to the 4th is part of du. Cosine is not part of either thing, so that's still there. X to the 5th is u, and then the 5x to the 4th times the dx is all du. All right, so I've got the integral of cosine of u du. And basically I've simplified the problem so that I can apply a basic integral rule that I already know, and that is the integral of cosine of u du. And the answer to that is sine of u plus c. But you're not done, because it needs to go back to, like, it needs to match the original here, right, with x's. And so then you substitute what u was equal to. That's why it's important to write it off to the side. And so then this becomes sine of x to the 5th plus c. Okay? So again, you're looking for something perhaps in the problem that is the derivative of something else in the problem. And that's usually how you can identify the pieces that you need for u substitution. And why do I need u substitution? Because I have more than just x in the problem, okay? All right, so let's take a look at the other one that we've already talked about, right, which was the integral of cosine of 7x dx. All right, we know what it should be, but I want to know how to get it using u substitution. All right, now I'm trying to, not only am I trying to think, is there something else in the problem that is the, is there something in the problem that's a derivative of something else? But I'm also thinking, does it fit the mold of one of my rules, right? Or does it kind of look like one of my rules? And it kind of looks like one of my rules, cosine of u, all right, if u was 7x, okay? So let's start with that. All right, now when we take the derivative, all right, and I'm going to show you a shortcut here in just a second. Like, so the idea is that we're always taking the derivative of u with respect to x, okay? And on the other side, we get 7. But you're always going to have to multiply this dx to the other side. So you might as well get into a habit of just going ahead and putting it over there. All right, so du is 7x dx. Oh, not 7x, sorry, just 7. 7 dx. Sorry about that. Okay, so if we look back at our problem, all right, we have cosine of u, the 7x is u, but then we have part of du, but we're missing the 7, okay? Now, because 7 is just a constant, you can compensate for it, okay? Meaning you can multiply in the constant that you need as long as you also multiply by the reciprocal, all right? And then I don't actually need the reciprocal in the integral, and so I am going to, because it's just a coefficient, I am going to factor it out to the front, okay? So I'm going to take it out of here, I'm going to factor it to the front. All right, so I still technically multiplied by 1. I did it with a 7 and a 1 over 7. I just put one of them in front and one of them inside. And as long as it's a constant, I'm allowed to do that. Okay, and so now the 1 over 7 is still part of my integral. And the dx times the 7 becomes the du. And so what am I actually integrating? I'm integrating, I have 1/7 of the integral of cosine of u du. All right, so when I integrate and there's a coefficient in front, that stays as part of my answer. And then I integrate what's inside. Well, the integral of cosine of u is sine of u. And then, of course, we need a plus c. And last but not least, you do have to plug u back in. Again, that's why it's important to keep up with it. And then you are finally finished. And if you look back to where we guessed and checked at the beginning, that was the integral of cosine of 7x dx. Okay? Now, let me see where we're at in our recording here. All right, that's 18 minutes, so I'm going to go ahead and stop this video here and then just start a new video creating several more examples.